Okay, good day everyone. Now we will be having a discussion about FCM or fuel conditioning module. So, Starting from the basics, the typical fuel used on board ships is the heavy fuel oil. Uh, this requires treatment before injection, but because of the ECA regulations, so um, it requires cleaner fuels like marine gas oil and other and um, LPG or other cleaner fuel alternatives. Okay, so the Alfa Laval fuel line. So, so you can see if we have fuel on board, we must put it first in the from the bunker tank or storage tank. We must put it first in a settling tank to settle down the impurities and drain the other impurities, and then put it in a separator or purifier to clean the fuel before putting it in the service tank. And then from the service tank or the day tank, we still drain water and other impurities that was left after the purification. So before entering into the engine, it will first go to a fuel conditioning system or fuel conditioning module or system. So in this system, the fuel is conditioned depending on the requirement of the fuel to the engine. So depending on the manufacturer's requirement. And then if there are sludge and uh, impurities in the fuel conditioning system, so it will be drained, or it will be put or flushed down into the sludge treatment. Okay, so now we will be focusing on the fuel conditioning system. So this is a fuel conditioning module. So this is a compact size. So fuel conditioning system for diesel engines. So in this small setup, it can still handle large engines. Okay, so what is the function of the fuel conditioning system? So the fuel conditioning system is pumping and heating system which delivers fuel oil from daily service tank to diesel engine under conditions specified by the engine manufacturer to ensure optimum combustion. So this is the setup. So from settling tank, uh, it will be delivered to the separator via the feed pump and going to a preheater to heat up the fuel before purifying it. So, and then after purification, it will go to the service tank. And then from the service tank, it will go to the FCM or fuel conditioning module and to the engine. While the FCM, the service tank, and the separator is controlled by a flow sink and also by a VFD. So this is a automation. And then the FCM has also still, even though we have used the purifier or purification, so the FCM still uses an automatic backwashing filter to be sure that the engine will have clean fuel in its injection system. So this is an example of our FCM. This is a schematic diagram of our fuel conditioning module. So we have here two different kinds of fuel, which we have the HFO and the MGO, a cleaner fuel. Then it goes through a changeover valve, and then going to two supply pumps with a return valve or regulating valve, and then goes to a flow transmitter, and then to a pressure transmitter, and then to the mixing tank, and then after that goes to the booster pump to boost its pressure, creating higher pressure, and then to a heater. So in this heater we can heat up the fuel, and then we also have here another setup, a three-way valve. So here we have a cooler. If ever you need it to cool, you need to cool it down, especially if you're using the cleaner fuel. So the cleaner fuel doesn't need high temperature, so it needs cooling. And then it goes to a pressure transmitter, temperature transmitter, and the viscosity transmitter. So depend, because different engines have different viscosity requirement based on the manufacturer's recommendation. So we will always follow the manufacturer's recommendation. And then an automatic filter here, automatic filter, and a manual filter also if ever there will be a problem with the automatic, so we can change over to manual for the meantime before the fuel goes into the diesel engine for fuel injection. And then we also have return line going back to the mixing tank. So this is the pressurized, we have the FCM schematic diagram. So there are different alternative designs for the FCM. It depends on what fuel are you using, how many fuels are you using. So scenario 1, we have a LPG. So if you're using LPG, we can have different alternative designs for our fuel conditioning module. So these are 3 scenarios using LPG as their fuel system for their diesel engine. So yeah, and then we will tackle on the most basic diagram. So this is the most basic fuel conditioning module, so we will be using this one for our current discussion. Okay, so the fuel conditioning module is a 2-stage pressurized booster system. So it has a low pressure and a higher pressure stage. So it uses viscosity as the primary control parameter. So we are using the viscosity requirement based on the manufacturer's recommendation. So pressure in the low pressure section is maintained at 4 bar pressure, while in the high pressure section we will be maintaining pressure of 6 to 16 bar depending upon the requirements of the engine manufacturer. So this is our schematic diagram. So number 1, we have here HFO and DO day tank. Number 2, we have a 3-way changeover valve. Number 3 are the strainers. 4, supply pumps. 5 is the automatic backwash filter. 6 is the filter pressure drop switch. 7, here we have the supply pressure control valve. 8, we have the flow transmitter. And then number 9 is the bypass. 10 is the pressure transmitter for the supply pump. This one, supply pump. So number 13 is, so we will go first for 11. So number 11 is the level switch. Number 12 is the automatic deaeration valve. So it's a deaerator, removes air. 13 is the mixing tube or the vent tank. 14 is the circulation pump or the booster pump. And then we have 15 heaters. 16 is the pressure transmitter. 17 is temperature transmitter. 18 is the viscosity transmitter or viscosity sensor. And we have here the engine. 19 is the engine pressure control valve. So that is our fuel conditioning module. So this fuel conditioning module is divided into two stages, the low pressure stage and the high pressure stage. So we will first discuss about the low pressure stage, the equipment and the function. Okay, so the low pressure stage includes two supply pumps here, number 4. One in operation and one on standby. If ever there will be a problem on the on the operating pump, so automatically the standby pump will start. Okay, next we have the automatic filter number 5 here. So with a manual bypass filter number 6 as a backup. So these are the parts of the low pressure stage. We have the flow transmitter number 8. So it provides information on fuel consumption. Next, the last part of the low pressure section is the mixing tank, where fresh fuel is mixed with hot fuel returning from the engine. So this is a mixing tank. The higher temperature and the low temperature fuel is mixing or is mixed in this area. So as engine speed changes, so will fuel consumption. So a special pressure control valve here, number 7. So a special pressure control valve allows fuel to recycle within the low pressure section. So if the engine is running low, so the excess fuel will go here in the special pressure control valve and going back to the suction line of the supply pump, so that the flow of fresh fuel entering via the three-way valve exactly matches the fuel consumption of the engine here. So the fuel that goes here exactly matches the fuel consumption in the engine. So if there is if the engine is currently in low speed, so the excess fuel will go back here on this line. Okay, should the supply pump in operation fail, then the system will automatically change over to the standby pump. So if this one is running, and then if this one fails, so the pressure in the pressure transmitter, it detects a low pressure, then automatically the other pump who is on standby, it will start, so that it will help in building up the pressure to prevent pressure loss in the system and may cause stoppage of the engine. Okay, so that is more on the low pressure side. Now we will talk about the high pressure stage or side. So we will still continue for the low pressure stage. So on the low pressure stage, as engine speed changes, so will fuel consumption. So this was already okay, so this was already discussed. Next, we have from the mixing tank number 13, the fuel enters the high pressure section. So the flow rate in this section is always set at a multiple of the actual fuel consumption rate in order to prevent fuel starvation, or to prevent that the engine will have less fuel, or we may stop or may slow down. So prevent fuel starvation at the injectors. So the flow rate multiplies and the pressure in the system are set by the engine manufacturer. So now we will be going to the high pressure stage. So the high pressure stage, it includes the circulation pump here, number 14, or also we call this one as the booster pumps. We have the fuel heaters and the viscosity transducer. So the viscosity sensor measures the viscosity of the fuel and sends a signal to the controller where it is compared with the value for viscosity set by the engine manufacturer. So deviations from the set point are then corrected by adjusting the flow of heating medium to the heater. So if the viscosity is very high, meaning the temperature is lacking, needs more heating, so it will send signal, the controller will send signal to the heater to increase its heating capacity or heating input, or to increase the heating depending on the deviations on the set point. So the pressure in the system here, the pressure in the system to maintain the pressure in the fuel injection system. So we have here number 19, a pressure relief valve after the injectors. So it is normally part of the engine installation, and the excess fuel returns to the mixing tank. So this one is the one who will be maintaining the pressure in the system. So why do we have to maintain the pressure in the system? So first, for better fuel injection. Next is to prevent accumulation of air or gases in the system, especially we are dealing with hot fuel. So especially the fuel is going up to more than 120 degrees Celsius. So if you will be dealing with high temperature fuel, so there will be gases that will be emitted because of the high temperature. So to prevent that, we must have to pressurize the system. Okay, so this is our diagram again. So what is the major advantage of the FCM? So usually on board there are fuel conditioning modules. So it is a compact design, a module. So it is a set, a complete package, while you can also buy equipment individually. So what is the advantage of a package system over an individually bought equipment making a system? Okay, so advantage of the FCM is it is a compact modular design. So its configuration is flexible, so you can change depending on your wants and needs. So and since it is compact, it is also a space saver. So we all know that on ships we greatly want that to save space, so that we can increase the space for our cargo. So having a FCM with a compact modular design greatly saves space for our ship, for the machineries, and for the cargoes. So next, this is a user-friendly layout. So it has user-friendly, so it is easy to access, easy for checking, for maintenance work. So that is another advantage of a module or a fuel conditioning module. Next, the components are pre-installed. The connections and controls are pre-installed. So it means that it saves time and installation man hours rather than buying loose components. So if you are going to buy one equipment at a time, so it will take time so that all these equipments will come or will go on board the ship, and then installation time will take time, and it is a very tedious job. So but if you have FCM, so the components are pre-installed, and the components are also pre-tested. So it is pre-tested system with approval for all function. So if you will install it on your ship, so it gives faster and more secure commissioning, right? Next, the use of pressure transmitter instead of switches greatly enhance control capability. So we have a user-friendly control and monitoring functions from one panel. So it doesn't have to go to different panels to monitor your system. Just one panel. We also have remote control, which is available in several options, up to full remote operation from a control room. So it depends on the owner. And then it has maximum safety for the engine with changing over HFO to DO mode. So automatic ramp function handles transition between two modes to prevent temperature shock to engine injection equipment. Okay, so this is our schematic diagram again. Okay, and then this is our FCM, fuel conditioning module. So the equipments are all behind this box or this cabinet or this controller. Okay, so we will discuss each equipment one by one. Okay, first we have the automatic changeover valve. So as you can see here, we have here the automatic changeover valve in this part of the FCM. So below it here we have the two supply from the DO service tank and the HFO service tank, whichever of them. So they are both suction from the service tank, DO and HFO. And then we have here the changeover valve. So the changeover valve, it is automatic. So to achieve safe fuel changeover without any thermal shock or fuel viscosity drop, since the temperature of the HFO and the MGO or diesel oil are different, so we should not have a fast changeover or a swift changeover. We should gradually change over from HFO to DO or vice versa, so to prevent thermal shock or fuel viscosity drops in the engine. Okay, next we have here the supply pumps here. So we have two supply pumps, so one on operation and one on standby. So the low pressure supply pumps, so oil from the day tanks enters the system via three-way valve and into the suction of the low pressure supply pumps. So operation of the section under pressure eliminates the problems of gasification and cavitation that are associated with high fuel temperatures 120 to 150 degrees Celsius. So this will ensure an even flow and prevent damage to the pumps. So we should always put pressure, or we should by using our supply pumps. So we are putting the fuel under pressure, so that we can eliminate the problem of gasification and cavitation. Next, we have here at the back of our module, we have the automatic filter. It's a block, so it's a complete package. So we have the automatic filter and the manual bypass filter and a changeover valve at the center. So the oil filters, an automatic backflush main filter backed up by a manual bypass filter, removes any particles present in the fuel that would cause engine damage. So continuous automatic backflushing and robust disc type filter elements guarantee high efficiency and minimum maintenance requirement. So as an alternative, the filtration stage can be moved over to the high pressure stage, but because of the higher flow rates, this normally will require a larger filter for a given engine. So we can put this filter on the low pressure stage or on the high pressure stage. Next, here we have the flow transmitter with bypass, or the flow meter, so it measures. Okay, so flow transmitter, so installed in the pressure side of the supply pumps to monitor fuel consumption. So that is its main function. So as an alternative, a mass flow transducer can also be installed. So a bypass valve is installed in case there is a problem in the flow meter or flow transmitter. Okay, at the back of our controller, we have here the mixing tank. So the mixing tank, or the mixing pipe with the aeration function. So as you can see at the top, we have here a deaerator. So this is the one that will degas or deaerate the mixing tank if ever there are gases in this part of the FCM. So this is where fresh fuel is mixed with hot fuel returning from the injector recirculation system. So gases that accumulate in the mixing pipe or the mixing tank are automatically vented back to the day tank. So a permanent air cushion within the mixing pipe dampens out pressure fluctuations within the system to prevent damage of parts, valves, screws, and other installations. Next, we have here at the back of our panel, we have the circulating pumps or the booster pumps. So the high pressure circulation pumps, dimension to give the total flow required by the engine manufacturer. So these pumps normally operate on a one-on-one standby basis. But should the pressure fall, then the system automatically activates the standby pump and triggers a pump shift alarm. So an indicator lamp shows which pump is in operation. Next, we have here the heat exchanger. So we have two heat exchanger, one in operation and one on standby again. So oil heaters, as standard, the FCM is equipped with a new M6 plate heat exchanger, especially designed for operation at pressures of up to 16 bars and temperatures up to 170 degrees Celsius. So this is accomplished by the use of special heat seal F high temperature gaskets. So the heating medium for the M6 heaters is steam, but shell and tube heaters for either steam or thermal oil can be supplied as an alternative. Okay, next we have the viscosity transmitter or the viscometer here, or viscotherm. So the viscosity transducers measures viscosity against a valve set by the engine manufacturer, and the controller adjusts the electrical valve actuator on the heating medium supplied to the heaters in order to maintain the correct viscosity. So if the viscosity is high, then it means it needs more heating. So it will send signal on this valve to increase heating or to decrease heating depending on the viscosity that it is reading. Okay, so this is the valve that will be controlled, and if there will be damage on this valve, there is a bypass valve also. And then on the return side of the steam, we have here a steam trap, and if ever there will be damage in the steam trap, so or during maintenance maybe, so we can also use the bypass valve. Okay, next here we have here the controller of the fuel conditioning module. So this is the control cabinet. So the control cabinet has two separate compartments. So a lower one that contains all motor starters, and an upper compartment that contains the EPC50. So this is the EPC50. Okay, so this is the EPC50B process controller and switches. So in here we can start the pumps. Which pump are we gonna start? The heater, we can start the program if it's automatic or manual depending on your preference. And on the bottom we have here a main breaker for our pumps and equipment. So we have here the automatic filter main switch, we have the supply pumps main switches, and the circulating pumps main switches. So this is the EPC50B controller. So we can push this to start or stop the system. We can either change over from HFO to DO, and then here if there are information that will be displayed there, and here if there is alarm, so you can push this one so that you can acknowledge the alarm. We have here the total running hours. You can choose yes or no in here, enter, and here we can use the manual mode or the EPC or the automatic mode. We have here for the regulating valve, we can decrease or increase the regulating valve. The heat tracing, so this one will be on, so that if the system will be stopped, so the cabinet will have a heater to prevent condensation in the electrical parts and to heat up the components. Here we have manual control, automatic control, stop, and remote control for our supply pumps and circulating pumps. And we have here automatic for automatic filter. We have the stop for the filter. We have the manual. You can use the manual filter, or we can drain or backwash the filter, or drain if you want maintenance. So this is the EPC50B controller. Okay. So the EPC50B process controller. So the controller monitors and controls the functions of the system and displays process values in here. So alarms, etc., and the clear text. So standard modes include diesel oil mode for startup and heavy fuel oil mode for normal running. So the system can automatically handle the changeover from DO to HFO with a temperature ramp and a ramp three-way valve. So self-cure functions include pump changeover from viscosity to temperature control, or even the reverse. In the case of failure and even changeover to diesel oil should there be a heater failure. So standard process readings include viscosity, outlet temperature, and instantaneous fuel consumption rate. Okay, so we will dive deeper on the function of our changeover valve. So, stricter fuel oil regulation imposed by the IMO and other authorities call over from heavy fuel oils to low sulfur distillate fuel oils in designated ECA or emission control areas. So the changeover from HFO to light fuel poses operational challenges, especially related to fuel viscosity, lubricity, and combustion quality. So onboard fuel oil systems must therefore be adapted to ensure the protection of fuel oil injection components. So there are also cooling units required to reduce the temperature of the low sulfur marine gas oil so that the fuel supplied to the engine is within the proper parameters to prevent too low viscosity. So we have the automated fuel changeover system. So the automated fuel changeover system is a reliable, fully automatic fuel changeover system that facilitates fuel oil changeover while maintaining fuel viscosity within the limits set by the engine manufacturers. So in the high pressure stage of fuel conditioning, so the ACS replaces the heating phase with the cooling phase in order to keep the distillate fuel temperature low and ensure the proper viscosity. So the ACS can be integrated with the Alfa Laval fuel conditioning module or any other booster system, new or existing. So features and benefits: compliance. It is in compliance with the new fuel regulations, achieve easy and fully automatic fuel changeover procedures, and handle up to 3 different fuels. So you can use HFO, DO, and another gas oil or gas fuel. So for safety, it provides cutting-edge control of variations in fuel temperature and viscosity. So this makes it possible to achieve safe fuel changeover without any thermal shock or fuel viscosity drops in the system. So integration, seamless communication between the ACS and the FCM for automatic and reliable fuel changeover procedures, full compatibility between the ACS and any fuel booster system from any supplier. So for automation, it provides fully automatic operation. Full process control is available from a remote panel also. And all process parameters allows full customization of the changeover procedure. So versatility, when needed, the ACS can utilize chilled water for cooling. So it is tailor-made. ACS version can be developed on request depending on the recommendation of the manufacturer and depending on the owner. So key components, except for pipes and cables. So the ACS scope of supply includes everything needed for a complete fuel cooling system, whether as part of a new installation or as a retrofit of an existing fuel supply system. So it is equipped with a heat exchanger that uses fresh water or seawater as the cooling medium, high corrosion resistance, and high efficiency and compact design. So the mixing valve is electrically operated, regulates fuel temperature by partializing the amount of fuel flowing through the ACS cooler. So the stepless flow adjustment allows exact temperature control of the light fuel in order to provide reliable temperature ramping and the correct final injection temperature and viscosity. So the temperature transmitter, so it has control unit with data about fuel temperature at the engine. So if you want 2 or more 3-way changeover valves, you can add more. Okay, so that's it for the automatic. Okay, operating principles. So operation of the ACS is based on an adjustable temperature set point and viscosity control determined by the FCM viscosity sensor. So change over from HFO to low sulfur fuel. So to initiate the switch from HFO to low sulfur fuel, the system gradually shifts the changeover valve from HFO operation to low sulfur operation. So if the ACS is integrated with an alpha level FCM, the control unit will reduce the heating power in order to control the fuel viscosity, because if you will be using low sulfur fuel or the cleaner fuel, and if it is still hot, or if it is still hot in the system, so those fuel like the diesel oil will have very low viscosity. So it is not also good for the fuel injector to have very low viscosity, since for the fuel injection, so if the fuel viscosity is very low, then the penetration of the injection of the fuel will be lesser. So the combination of the valve setting and continuous control of heating power ensures a safe and gradual changeover without the risk of a thermal shock. So once the programmable temperature set point has been reached, the ACS shifts the changeover valve from the heater position to the cooler position and begins to control the fuel temperature during the ramping phase by operating the three-way mixing valve. So continuous control of this three-way mixing valve ensures the correct fuel temperature and viscosity. So if you want to change over from low sulfur fuel to heavy fuel oil, so the low sulfur fuel is has temperature of around 30 degrees, while the HFO has a temperature of around more than 120 degrees. So colder from cold fuel to hot fuel. So to initiate the switch from low sulfur fuel to HFO, the system gradually shifts the changeover valve from low sulfur operation to HFO operation. So if the ACS is integrated, the control unit will ramp up the fuel temperature, so the temperature will be increased by operating the three-way mixing valve. When the programmable temperature set point has been reached, the ACS gradually shifts the changeover valve from the cooling position to heating position. So the booster controls the temperature ramping until the HFO working viscosity has been reached. So handling of three fuels as an option. So the system can handle three different fuels when applicable. So this allows money to be saved by using the most suitable fuel at any given time. Okay, so that's it for the fuel conditioning module. I hope you learned more from the systems on board ships, and I hope to see you on our next video. So goodbye, God bless everyone, and see you on the next one. Thank you.